So for this deep dive, we're looking at a few, well, seemingly unrelated subjects that just really caught our eye this week. It's our final review of the week before Christmas 2025. And we are diving headfirst into some of the paradoxes of technology. We're going from a Swiss AI designed to literally heat your apartment block all the way to the surprising resurgence of USB sticks in global resistance movements. And then we'll get to these startling new robots that are learning to do backflips without a single line of manual code. It's a snapshot of late 2025, and as always, we've had the key insights from the best sources summarized for us by Notebook LM.
It's definitely more than just a snapshot. I mean, what you're describing is a look at the emerging landscape of really technological autonomy and resistance.
Resistance, okay.
I like that framing. Yeah, we're talking about three massive shifts here. First, a real challenge to the U.S. dominance in AI, but one that's focused entirely on ethics and sustainability.
Okay.
Second, the enduring power of low-tech offline networks to bypass censorship and infrastructure failure.
And the third one is the robots.
The third is that breathtaking leap forward in what we call embodied AI, robotics intelligence.
So if you're listening and you're thinking about a Swiss data center, Cuban hard drives, and an acrobatic robot, you might be struggling to find the connection. You're saying the common thread is resistance. Mm-hmm. How does a self-heating AI resist anything?
Well, it resists the dominant model, right? The centralized, surveillance-driven model that currently defines the AI landscape. It's resistance to information overload, resistance to digital surveillance, and in the case of the robot, you could say it's resistance to the physical limitations that are normally imposed by human programming.
I see.
So these technologies, whether they're incredibly high-tech or surprisingly low-tech, they're all about seeking autonomy in a world that's increasingly dominated by giants.
Be it big tech.
They really are. And it's a smart play. While you have OpenAI, Google, and Meta locked in this escalating war over performance, burning through gigawatts of power.
And billions of dollars.
And billions of dollars.
Right.
There's this growing space for alternatives that compete on totally different metrics. Things like sovereignty and trust. Uria is a prime example of that pivot.
And their core promises really reflect that. They're targeting sectors that just cannot afford any risk. We're talking sovereign AI, hosted entirely in Switzerland. They guarantee absolute confidentiality, no user profiling, and this is the big one, no training on user data at all.
That last point is a total game changer, especially for sensitive fields. Think about it. Health records, legal strategies, proprietary financial data.
Government communications.
Absolutely. In those sectors, even the hypothetical risk of your data feeding into some global model is a complete non-starter. So their commitment to compliance is everything. They're compliant with RGPD and LPD.
For our listeners who might not live and breathe compliance, can you quickly break down what that really means, the weight of that?
Sure. So RGPD is the EU's General Data Protection Regulation. It's really the global gold standard for how personal data is handled. And LPD is Switzerland's own, often stricter, version of those principles. It really emphasizes data localization and user control. So their compliance means everything is encrypted and stored exclusively in certified Swiss infrastructure. They even have an ephemeral mode where the system literally retains nothing.
It completely removes that what-if question about where your data is and what it's being used for.
It does. It builds a level of trust you just don't get with the big players.
So strategically, Infomaniac isn't trying to build some massive monolithic LLM from scratch to compete with Google. That would be insane. They've gone a much smarter route, an open-source orchestration strategy.
That is the technical elegance of it. Instead of reinventing the wheel, Uria uses what they call a bouquet of leading open source models.
A bouquet, okay.
Yeah, and they host them entirely on their own infrastructure.
Yeah.
So we're talking about leveraging top-tier models like Mistral's Mixtral 8x7b, even the 8x22b, also Llama 3 from Meta, and specialized tools like Whisper from OpenAI for really accurate audio transcription.
So the user gets performance that, rivals or even matches GPT 3.5, maybe GPT 4 for a lot of common tasks.
Right.
But with none of the data collection or the privacy compromises that have become the standard, it really is the best of both worlds.
And you see that power in its functions. It's not just a chatbot. It can generate complex code, transcribe hours of audio, analyze huge PDFs or Excel sheets.
It's a full AI assistant.
A full high-security AI assistant, yeah. And it's integrated into their K-Suite ecosystem.
I also thought the way it conserves energy was really clever. If it can answer your question from its own internal knowledge, it does. It only goes out to the web for a search if it absolutely has to get fresh info. It's stingy with its resources by design.
And that efficiency is a core part of their identity. It feeds directly into their commitment to environmental responsibility. Plus, they've been incredibly generous with access. It's free for the public. You don't even need an account for basic stuff.
Which brings us to the most, I think, revolutionary part of this story, the sustainability claim. It's not just about being green, it's the idea that the AI's infrastructure is designed to literally heat apartment blocks in Geneva. It's turning computational waste heat into a public utility.
That's the whole innovation of their D4 data center. I mean, historically, data centers are just these massive heat vents, huge waste of energy. D4, on the other hand, is designed from the ground up to harvest that heat.
So walk us through the mechanism. How do you get from warm server air to hot water for radiators?
Okay, so the air coming off the servers is around 45 degrees Celsius.
Hot, but not hot enough for district heating.
Exactly. So that air is captured and run through a high-efficiency air-to-water exchanger. That's step one. Then comes the critical part. Industrial heat pumps take that water and boost the temperature way up. They can get it to 67 degrees, and in the middle of a Swiss winter, they can push it all the way to 82 degrees Celsius. That superheated water is then injected directly into Geneva's district heating network.
So every time someone uses Urea to summarize a report or generate some code, the heat from that computation is literally helping to warm a home down the street.
It creates a true symbiotic loop. This is way beyond greenwashing. The numbers are they're staggering. The system is projected to valorize 14 gigawatt hours of energy a year at full load.
14 gigawatt hours. To put that in human terms, that's like the annual heating for about 6,000 homes.
It is. And by doing that, they offset the need for gas heating, saving an estimated 3,600 tons of CO2 every year.
That is a new benchmark.
It has to be. Their power usage effectiveness, or PUE, is 1.11.
And a PUE of 1.0 is theoretical perfection. Right?
It's the holy grail, yeah. Most data centers are running at 1.5, even 2.0. So they're using almost as much energy on cooling as they are in computing. Yeah. A PUE of 1.11 is just phenomenal.
Okay, so it sounds perfect. Ethical, sovereign, high-performing, green. But using that bouquet of open source models doesn't magically fix the fundamental flaw in all LLMs, the critical warning about hallucination.
Exactly. That security and efficiency strategy is great, but it doesn't fix the core instability of these models. The testing on Urea revealed what the source called a spectacular hallucination.
The test was about the corporate history of the publication Frandroid, something the tester knew inside and out. And Urea just confidently stated that Frandroid belonged to the Webedia group.
And it got worse. When the tester asked it to verify that information, Urea doubled down. It invented an acquisition date 2013 and presented this lie under a heading that said verified details, complete with little green check marks.
And that's the real danger, isn't it? It's not just that it's wrong. It's that it's wrong with such confidence. The format, the language, the check marks.
Yeah.
It's all designed to make you trust it.
That's the core challenge of every LLM, whether it's in Silicon Valley or a green Swiss data center. The polished output hides the factual inaccuracies. So the lesson for you, the user, is clear. Urea is an amazing tool. It will probably handle 95% of your daily tasks perfectly, summaries, emails, translations. But for those critical, precise facts, you have to verify. You cannot outsource your critical thinking.
Okay, so if Urea offers digital autonomy by resisting the centralized cloud model, let's pivot to how the Sneakernet achieves autonomy by resisting state-controlled infrastructure. We're going from an ultra-green data center to something beautifully low-tech.
It really is. The Sneakernet, literally the basket network, is just the physical transfer of data on storage media, USB keys, hard drives, you name it.
Moving data with your sneakers.
Basically, yeah. It's a physical data protocol. It bypasses fiber, 4G, all of it.
And in the West, we might think of it as a way to avoid digital surveillance, moving big files off the grid. But globally, its role is so much more profound. The sources called it salvational.
It is. It's the modern heir to clandestine systems like the Soviet samizdat, that old network for circulating dissident literature. The Sneakernet thrives where the internet is either censored, too expensive, or just doesn't exist. It's the internet for the internetless.
So let's look at some examples of how this actually works, where it's a lifeline.
We can start with North Korea, probably the textbook example of a state with absolute information control.
Right, and in June 2024, there was that incident dubbed the War of Balloons. This wasn't just political theater, it was a physical data dump.
A huge one. Dissidents in South Korea launched hundreds of helium balloons across the border, and the payload was this fascinating mix of political and cultural resistance. 200,000 anti-regime brochures, US dollars, and crucially, USB sticks loaded with K-pop and K-dramas.
It's not just political texts, it's cultural soft power. It attacks the regime's control on two fronts: the political narrative and cultural consumption.
Exactly. It's psychological resistance, enabled by physical data transfer. Now, contrast that with Cuba, which is a very different set of problems. There, you find the institution known as El Paquete Semanal, the weekly packet.
Right. In Cuba, the problem is a mix of the long-standing U.S. embargo, which means infrastructure is ancient, and heavy government censorship. Internet access is incredibly slow and expensive. We're talking about $2 an hour.
So El Paquete stepped into that void back in 2008. It's a 1 terabyte collection of Western media, curated every single week. Movies, music, TV shows, digital magazines.
And it's basically the Cuban Netflix. It's an entire parallel industry. How does that even work, distributing a terabyte of new data every week?
It's surprisingly organized. You have curators who have access to fast internet, they download everything, and then replicate that master 1 TB drive onto hundreds of other drives. Those drives are then sold to regional distributors who then sell copies or rent out the data transfer to local households for a small fee.
And it's this informal economy that sustains the cultural life of the island. It's a bypass that the government kind of has to tolerate.
They do. It's a necessary pressure release valve. Now, that's a semi-tolerated system. Look at Afghanistan after the Taliban returned in 2021. By September 2025, you had a major digital blackout. Over 43 million people were digitally isolated.
In that case, the Sneakernet didn't just supplement the internet.
It replaced it. The whole system ran through what they call computer cars. Computer cars. Data mules transporting files clandestinely.
What were they moving?
Vital information. International news. Online educational courses. Everything from coding to literacy software updates. Things you just couldn't get anymore. They'd sell these files from the trunks of their cars in remote areas operating on trust. A literal black market for information.
But it's not always about censorship or state collapse, right? It also just solves the simple problem of white zones, places with no reliable infrastructure.
Exactly. In those cases, the data mule isn't dodging censors. They're just connecting two places that can't be connected digitally.
Yeah.
A city's cybercafe to an isolated village.
Like in India's Ladakh region in the Himalayas.
Right. Messengers carrying administrative documents and school results. And that model still works. Look at the Trotros project in Ghana.
The minibus drivers.
Yeah, the local minibus drivers act as data mules, ferrying hard drives between cities and villages to update local agricultural and health databases. It's low-tech, it's resilient, and it's effective. It solves a problem that even the most advanced AI can't impart: the basic challenge of physical connectivity.
Okay, let's shift gears completely. From the challenge of connectivity to the challenge of physical capability. We're going to Mark Rabert's new project. This feels like a massive leap into the future of physical embodied AI.
It absolutely is. Mark Rabert, the founder of Boston Dynamics, the man behind Atlas and Spot, is now at the RAI Institute, and he's focused on the Ultra Mobility Vehicle, or UMV.
And its inspiration is just incredible. It's bike trial riders. Those acrobats on bikes doing wheelies and backflips on impossible terrain.
And that's the goal, to create a robot with genuine athletic intelligence. They want to combine the speed and efficiency of wheels with the jumping and mobility of legs. It has to master dynamic equilibrium in real time.
Let's talk about the hardware. It's about 23 kilograms, but the key is its adaptability. It can shrink down to 80 centimeters or extend up to over 1.5 meters.
And the motor setup tells the story. 2 motors for basic direction and speed, but then 4 dedicated motors just for jumping. Lift and maneuverability are the priority.
The design also mimics an athlete. A lightweight carbon fiber frame, but the top section acts as a movable counterweight.
That counterweight is essential. It's just like how a human trial rider has to aggressively shift their body weight to maintain balance during a wheelie or a flip. The robot is constantly managing that center of mass.
And the results are? Well, they're stunning. 1-meter jumps, sustained wheelies, forward flips with perfect landings.
The feats are impressive, but the breakthrough isn't what it can do. It's how it learned to do it. The robot was not manually programmed for any of this. No engineer wrote the code for a backflip. It learned everything on its own.
So this is deep reinforcement learning, or RL. Can you walk us through that? How does a robot learn a backflip without instructions?
So with RL, an agent, in this case, the robot learns by interacting with an environment and getting rewards or penalties. The UMV was put through millions of simulations in a hyper-realistic virtual world, NVIDIA's Isaac Lab.
So in the simulation, it tries a move. If it works, it gets a reward. If it crashes, penalty.
Precisely. It learns through millions of virtual failures and successes. The AI, not a human, develops this intuitive understanding of its own Physics, mass, momentum, force.
And then came the really startling part, the zero-shot transfer. They took the skills it learned entirely in the simulation and just uploaded them to the real robot. No real-world testing or tweaking.
And it worked. That's the defining success. The source material used a great French phrase to describe it. Débrouille-toi, mon grand.
Which is something like, figure it out yourself, big guy.
That's exactly it. Because that's what the robot did. The zero-shot transfer proves it developed a generalized, robust understanding of physics, not just a memorized routine. This is what Rabert's team is calling athletic intelligence.
So we're really in the era of embodied AI now, intelligence that has a physical body and learns to use it athletically, not just mechanically.
And the implication is profound. I mean, if RL can master this level of dynamic equilibrium today, how quickly will humanoid robots be able to navigate the most complex, unstructured terrains in the real world?
They're learning to be agile faster than we can code it.
Much faster. So the next step is obvious. You integrate high-performance perception, LiDAR, cameras.
And once you pair that athletic intelligence with vision, you get true autonomy. It won't just know how to do a backflip. It'll know when and where to do one based on its surroundings.
It's a trajectory that suggests a future where embodied AI can outperform humans in physical adaptability in almost any environment.
So today, we've done a deep dive into three major forces: the greening of AI with Uria, the resilience of low-tech networks like the Sneakernet, and the startling advance of robotics with the UMV. Technology is getting greener, more resilient, and more agile, all at the same time.
If we go back to that central theme of autonomy and resistance, you see this powerful duality. On one hand, you have the digital autonomy Uria provides through privacy, a choice to be free from surveillance. And on the other, you have the physical athletic autonomy of the UMV robot, which masters the physical world on its own terms, free from human scripting.
Which leaves us with a final provocative thought. These systems are all moving toward greater independence, and they're doing it fast. Uria uses the waste heat of computation to serve the public. The UMV uses computation to redefine physical independence. What happens when these two domains really intersect?
Think about that convergence. If a hyper-efficient, sovereign, learning AI, like the kind running in that Swiss data center, gains control over a hyper-agile physical form like the UMV, where does that leave human control? I think we have to stay vigilant about our digital security, but also about the incredible pace of physical robotics, because the future of autonomous systems is developing its own unscripted knowledge of both worlds, the digital and the physical.
Thank you for joining us for this deep dive. If you enjoyed this analysis, please help us reach 2,000 subscribers and share the podcast de Philippe with a friend. We will be back next week.